In this lesson, we are going to review multiples, finding the least common multiple, and then we're going to move into when we would use that with comparing fractions. So if you recall, we said that factors and multiples work hand in hand. We said that a factor times another factor ends up with a multiple. In the example we used the other day, we said that 3, which is a factor of 12, times 4, which is a factor of 12, results in 12, which is the multiple of 4 and the multiple of 3. Then we moved into discussing the LCM, or the least common multiple. And we said that we can figure out the LCM of a set of numbers by using something called, what I call the popcorn method. Here, again, we are talking about finding the least common multiple of 3 and 4. And the way we would do that is we would popcorn back and forth until we find a common multiple. So we start with 1 and we multiply it times whichever number set we're trying to find the multiple of. So in this case, we're trying to find multiples of 3 and 4. So we're going to start over here with our 3's. 1 times 3 is 3. We go over here to the 4's. 1 times 4 is 4. No match. So we popcorn back over here and we go 2 times 3, which is 6. Still no match. And we keep going back and forth until we come across a common multiple. And the reason that we do it this way, starting with 1 and working our way forward, is because when we do that, we will definitely find the least common multiple once we come across to the very first one that's common, in this case 12. We also talked about another method that you can use, which is also appropriate, which is our factor trees. So you don't do the factor trees any differently than what we've learned before. In this case, we're trying to find the least common multiple for the number set 15 and 20. So you can see here that we've gone ahead and factored them. We have found the common factor, which would be 5. And so we're going to use that one time right here. You'll see here that we have a common factor, 5 and 5. And because it's common to both of them, we only use it once. Then, unlike when you're finding the greatest common factor, at this point, this is the part that's different. We're going to pull off every other factor that is prime that we haven't used. So we haven't used this 2, so we're going to use it here. This 2 is also something that's not common, so we're going to use it. And then the 3 is not common, so we're going to use it. You'll notice we only use the 5 once, even though it's here and here. Because it's common, we only use it once. Then we use every other factor that's left. When we multiply them together, we get 60. You can also see the popcorn method listed here as well, and you'll find that the result is the same. So I really don't care which method you choose to use. You're going to probably find both of them appropriate at different times depending on the number set that you're looking for. So then you say, well, why are we even having to do this? Well, that moves us into what we're going to talk about today, which is comparing fractions. So in your book, right here, if you look in your book on page 583, that's where you're going to be able to reference from your textbook, comparing fractions. My dog just bumped into me, so yes, I see you, Marley. So anyway, when to use a common multiple? Well, when you're comparing fractions, it's important for us to be able to. Have you ever heard the phrase, comparing apples to apples? That's kind of what you're doing when you're comparing fractions. You can't really compare oranges to apples. They're not the same fruit. This orange isn't necessarily better than this apple because they're two totally different things. But you can compare, maybe it's a Macintosh apple to a Gala apple because they're both apples. There you can compare them. Well, fractions are the same way. We have to be able to compare the same thing. So in order for it to be the same, we have to have common denominators with our fractions. So I'm just going to use this example just because I think it's easy to explain using numbers that we're pretty familiar with. Here in this case, if we were trying to determine whether 1/3 was bigger than 2/4, some of you might be able to visualize that in your head and you may be able to figure that out, but I'm going to still show you the method with this one. That way, when we get into harder fractions, you'll still use the same concept that you did with this one in the harder method or harder fraction. So here we're going to be comparing 1/3 and 2/4. You'll notice that the very first thing I did is something that I call stacking them. And that means that you want to put them one on top of the other. It's important for us to get into this habit now because this is going to help us when we learn to add and subtract fractions. So when we stack them, that's not a math term, that's a Mrs. Greenlee term. You're going to do this. Put one on top of the other. Doesn't matter which one you put on top or the other. And then you'll notice I have equal signs here. Because remember, just like with decimals, you can call this fraction a different name, but they have to be equivalent. They have to be equal. Just like I can say a quarter is the same thing as 5 nickels because it's both equal to 25 cents. We want to make sure that we're creating an equal amount, something that is the same thing as 1/3, something that's the same amount of candy in this hand as in this hand. So we want to do that for 1/3, and then we also want to do the same thing for 2/4. But because we are comparing these two fractions, we have to come up with a way to make them equivalent using the same denominator. Well, you can't just pick your favorite number. I can't just say, oh, well, 15, because 3 divides into 15. That'll work. Okay, well, what about 15? Is 4 a factor of 15? No. So you have to have common multiples here. 15 might be a multiple of 3, but 15 is not a multiple of 4. I can't multiply something times 4 to get 15. Okay, I hope that that's making sense to you. So what I have to do is I have to figure out a common multiple for 3 and for 4. Well, we know that 12 is a multiple of both of them. And if you're not sure, you can always do one of the methods that we've learned about. You can do the popcorn method, or you can do the factor trees. Another method that actually will work, that some of your parents may say you can do this, is just to multiply the two denominators together. You won't always get the least common multiple, but that will always work because when you multiply factor times factor, the answer is going to be a multiple. Does that make sense? So that means your multiple would work. So you could do that, but I'll show you why that's not always the best thing to do, but it is certainly something that you can always 100% of the time do, but you might have to work with harder numbers if you do it that way. Okay, getting back to this. So we determined that 12 is a multiple of both 3 and 4. And so now what we're going to do is, in order to make them equivalent, we're asking ourselves, okay, what did I do to the 3 to get to 12? Well, I would multiply it times 4. See that? And you might recall, and you'll see this in your book, and this is the part that I said to you before was a little bit confusing in your book. They have that big old 1 over here because they're telling you that whatever you're multiplying the 1/3 by is giving you an equivalent of fraction. So they're saying to you, oh, you're just multiplying it by a form of 1 whole, which is what you're doing. So whatever you multiply the denominator times by, here 4, because you would want it to be the same for the numerator, 4/4 is what you're going to end up with. That's what you're multiplying it by. In other words, it's a form of 1 whole. Okay, and so that in your book, it can look a little bit tricky. That's all that it's trying to tell you, is that you're multiplying 1/3 times a whole, whatever that form is. In this case, the form of 1 whole is 4/4. Okay? Just keep in mind that whatever you do to one part of the fraction, you have to do to the other part of the fraction. So because we're trying to find this missing number here, we have to multiply whatever we multiplied the denominator times. 3 times 4 to get 12. We're going to do the same thing to the numerator. So 1 times 4 equals 4. Okay? So let's do the same thing down below. How do I go from 4 to 12? What would I have to do? Well, I would multiply this. 4 times what to get 12? 3. Well, because I'm multiplying 2/4 times a whole, the denominator is a 3. That means the numerator has to be a 3 as well. So I'm going to do the same thing to the numerator. 2 times 3 equals 6. Okay? And once I have common denominators, then I can compare them simply by looking at the numerator and saying, well, which one is the larger one or which one is the smaller one, depending on what's being asked. So in this case, 4/12 is less than 6/12. So I have to go back then and say, well, 4/12 is the same thing as 1/3. So 1/3 is less than 2/4. Does that make sense to you? I hope it does. Okay. there's a time that you might not want to just multiply the denominators together because you might end up with this really big answer. For instance, if you're trying to say to yourself, or if the problem says, is 9/20 greater or smaller than 35/60? Okay, so now let's copy this down. I don't have enough whiteboard space, sorry. So if I'm trying to compare let's do it this way, 9/20 and 35/60. Based on what I just told you, you could do 20 times 60 to get a number. Okay, in this case, it would be 1,200. Do you really want to work with 1,200? Could you? Will it work? Absolutely. But that's a really big number to be working with. And then if you have to simplify it, that gets a little bit tricky. So that's the reason that even though I'm telling you, you can, and your mom and dad might say the same thing, you can multiply your two denominators to get a common multiple, that will work. But just be careful, because if you do that, you might end up with a really large denominator that's not really easy to work with. That's why I want you to get into the habit of learning how to do either the popcorn method or the prime factorization trees. Okay, so in this case, if we have 20 and 60, I thought I had this one already listed out. Yeah, here we go. No, I guess I don't. Okay, we'll have to do this one together then. If I have 20 and 60, we can count by, 20, 40, 60, 80. So what's the very first multiple that's going to be common? See if you can figure that one out. 20, 40, 60. 60, right? Because 20 times 3 is 60, and 60 times 1 is 60. Okay, so I know that 60 is going to be a common multiple. Because I'm using the same denominator here as my original denominator, I'm just going to bring over the same numerator. Up here now I have to figure out, well, how did I go from 20 to 60? What do I multiply 20 times to get 60? Or you could ask yourself, what do you get when you divide 60 by 20? However your brain works the best to figure that out, you're doing the same thing. So either way is fine with me. So you can say 20 times 3 equals 60, or you could say 60 divided by 20 is 3, either one. But whichever method you're using, whatever you do to the bottom, you're going to do to the top. So realize that you're multiplying the 20 times the 3 to get 60. So that means I'm going to multiply my 9 times my 3 to get 27. So I have 27/60 and 35/60. Well, which one is the smaller one? Right, this one. So which one is smaller, 9/20 or 35/60? 9/20. It's really important for you to go back into the problem, into the question, just like we did in the beginning of the year when we were comparing decimals. Excuse me. You've got to go back into the question and say, okay, how does this fit into what it's asking me? Is it greater than, less than, or equal to? Because it all depends on which side of the problem the number is on, the fraction is on. So if it says 9/20 is something to 35/60, you guys see that okay? And I have to fill in greater than or less than or equal to here. It all depends on which comes first. So because I know that this is the smaller one and it's coming first in my equation, I would say 9/20 is less than 35/60. Okay, so if the 35/60 were on this side, then I would say that it would be greater than 9/20. So hopefully that's making sense to you. Okay, so what I would like for you to do is you're going to practice on page 385 in your textbook. I want you to spend some time practicing those problems. If you want to go on to 386, you can, but I just want you to make sure that you're solidifying page 585. You certainly can ask for help with this. This is like an in-class help assignment that I would be helping you with. You can reach out to me if you're not sure. You can ask mom or dad, to help you, or you can wait and ask me at a Zoom meeting. All right, have a good one.